Hey friends, my name is Yi and you're watching MakesItEasy. Welcome to a new video for IGCSE at Maths, and today we have questions for Binomial Theorem. And we looked into the rules and examples last lesson, and I'll link it in the description if you haven't checked it out. And before you get into it, don't forget to leave a like, subscribe, and ring the notification bell so that you don't miss out on any future videos. And we'll get right into some questions. Number 1. Expand and find the expression 1 minus 2x to the power 5. So let's just write it out. 1 minus 2x. 1 minus 2x to the power 5. So remember, to expand binomial, you have to start from the first term. So it'll be, the first term will be 1 over 5. Sorry, 1 to the power 5, which is just 1. Close bracket. Second term, 1 to the power 4 times 5c1 times by minus 2x. Close bracket and close bracket. And there's something I have to say, which is just this part right here. It's technically just 1 to the power 5 times 5c0 times minus 2x to the power 0. But they're all technically equal to 1 if you times it out, so it doesn't really matter if it's like 1, the a is 1. So we can just ignore this part. So the third term is plus 1 to the power of 3 times 5c2 times by minus 2x squared, like so. And the fourth term will be 1 to the power 2 times 5c3 times minus 2x cubed, like so, plus the fifth term, 1 to the power 1 times 5c4 times minus 2x to the power 4, plus the last term, which is 1 to the power 0 times 5 to the power of, 5c5 times minus 2x to the power 5. And just simplify this. And if you haven't checked out last lesson, and if you're not sure how to expand like binomials, just know that let's zoom in here. 5 minus 5, which is attached to the combination, is equal to this value right here. So like 4 minus 5, so 5 minus 4 is 1, 5 minus 3 is 2, and whatever it's minus against, the bottom number for the C, the combination, is equal to this power right here. So you can see 4, 4, 3, 3, and so on. Oops. And now I'll just simplify this. I'll just rub the top out. And this will equal to, if we expand everything, it will be 1. The first term is 1. The second term will be minus 10x, which I already rubbed it out. But the third term, which is this one right here, which has a power of 2, is equal to plus 40x squared if you just type into your calculator. And the fourth term will be minus 80x cubed. The fifth term will be plus 80x to the power 4. And the last term will be, oops, I'll just write it here, minus 32x to the power 5. So notice how when there's a negative sign, notice how when there's a negative sign right here, it will be an alternating series, like a plus, minus, it's an alternating series. And question 2, 2x minus 3 to the power of 6, and I'll just limit it to up to the power of 3, so that I can be lazy. So it will be equal to 2x minus 3 to the power of 6. So actually, I'll just flip this around so that it's easier to control. It will be minus 3 plus 2x to the power of 6. So the first term will be minus 3 to the power of 6. The second term will be minus 3 to the power of 5 times 6c1 times 2x, like so. And then plus the third term, minus 3 to the power of 4 times 6c2 times minus 2x, sorry, just 2x, times by 2x to the power of 2, and plus the last term of minus 3 to the power of 3 times 6c3 times 2x to the power of 3, and you need to put plus dot dot dot. And if you add everything up together, you get a final answer of minus 3 to the power of 6 will be equal to 729. And this is a cool trick to know, is that when you have a negative integer negative whole number in the inside of a bracket, and if it's raised to an even power, the result would be a positive number. But if minus 3 were to be to the power of 5, like an odd power, it will result in a negative number. So 729 minus the second term right here will be 2916x. The third term will be plus 4860x squared. And then the fourth term will be this one here, right here with x to the power of 3, which is equal to 4320 after putting in your calculator, like simplifying it, x cubed and plus dot dot dot, and that's the answer up to x cubed. Now number 3, expand the expression x plus 1 over x to the power of 6. And for this case, I'll just expand everything out because it's quite different from like the usual one, so that I'll show you guys the whole thing. So x plus 1 over x to the power of 6. So this will equal to, the first term is x to the power of 6, it's quite unusual. Second term, x to the power of 5 times 6c1 times 1 over x, plus the third term, x to the power of 4 times 6c2 times 1 over x squared, because we can just do 1 over x to the power of 2 straight away by just squaring the x in the denominator. And the fourth term will be x to the power of 3 times 6c3 times 1 over x cubed. And then the fifth term will be x to the power of 2 times 6c4 times 1 over x to the power of 4. And then the sixth term will be x to the power of 1 times 6c5 times 1 over x to the power of 5. And then the last term will be x to the power of 0, which is just 1, times 6c6 times 1 over x to the power of 6 right here. And we'll just simplify it now. So the first term right here will just be x to the power of 6. So x to the power of 6. And the second term, 6c1 will equal to 6, so plus 6. But here, the second term, the first value is x to the power of 5. You have to times it by 1 over x. So it's basically x over 5 divided by x, which is just x to the power of 4. So notice that, the different like x where you divide it in times. And the third term, we have 6c2 right here, which is just equal to 15. And x to the power of 4 divided by x to the power of 2, which is just x squared. Then moving on to the fourth term, 6c3 will be equal to 20. So here we have actually x to the power of 3 times 1 over x to the power of 3, which results in just 1, because x to the power of 3 divided by x to the power of 3 is 1, right? So this term is a constant, and we call this like the value which is like the independent of x, because there's no x. And then we have 1, 2, 3, 4, fifth term, plus, I'll just write here, like here, as you know, 6c4, which is equal to 15. So here, interestingly, the power x to the power of 2 times 1 over x to the power of 4. And if you write it out, it'll be like this. And this will have x to the power of 2 in the bottom, because you divide x to the power of 2 by the top and bottom, and it will result with 1 over x squared. So 1 over x squared times 15 will be 15 over x squared. So, and then we have 6c5, which is equal to 6. And as we know, it will be a fraction, so divide by x to the power of 1 times 1 over x to the power of 5, which is just x to the power of 4 in the bottom. So x to the power of 4. And then lastly, in the last term, x to the power of 0 is just 1, right? So it will result in x to the power of 6 in the bottom. And 6c1 is just 1, so it's just 1. And that's the answer. Then we have question number 4. Expand the expression 4 minus 3x to the power of 3. So we'll just do this now. 4 minus 3x to the power of 3. Oops. 3. So it will equal to 4 to the power of 3 plus 4 to the power of 2 times 3c1 times minus 3x plus 4 to the power of 1 times 3c2 times minus 3x squared plus 4 to the power of 0 times 3c3 times minus 3x to the power of 3, like so. And after expanding everything, you get a value of, let me just write it out. So 4 to the power of 3 is 64. And the second term right here is 4 to the power 4 squared times 3c1 times minus 3, and it'll be minus 144x. The third term, 4 to the power 1 times 3c2 times minus 3 squared, it will be plus 108x cubed to x squared. And then the last term will be a minus because it will be 4 to the power 0 times 3c3 times minus 3 cubed, which is equal to minus 27x cubed. So, and we're not done yet because we have to find 12 to the power of 3. So of course you can just use like common knowledge like 12 to the power of 3, but since this is just binomial, we can use binomial technique. So if you notice in the bracket, let me just zoom in, they're both to the power of 3. So you can actually just relate what's inside the bracket. So 4 minus 3x and 12. So since we already expanded the whole 4 minus 3x to the power of 3 right here, we can actually substitute each value of x by a certain value to find an outcome. So here's what I mean. So we have 4 minus 3x. We can just equate it to 12 because they're both inside the bracket into the same power. And if you solve for x, it will be minus 4 minus 12, or minus 12 plus 4, it's minus 8 equals 3x, and x equals minus 8 over 3. Right? So you can actually substitute x equals minus 8 over 3 to this equation right here to find what 12 to the power of 3 is. So if you do 64 minus 144 times minus 8 over 3 plus 108 minus 8 over 3 squared plus, minus 27, 7, and minus 8 over 3 cubed, or you know what I mean. So if you type in your calculator, it will be, let me just type it out, 64 minus 144 times by minus 8 over 3 plus 108 times minus 8 over 3 squared minus 27 times minus 8 over 3 cubed. And that will give us a value of 1671.11 rounded to 2 decimal place. And the actual value for 12 to the power of 3 is 1728, which is close enough to 1671. And that's the answer. Then moving on, we have find the coefficient of x to the power of 5 in the expansion of 3x minus 2 to the power of 8. So let's just rewrite it to become, let me just swap it around too, so it will become minus 2 plus 3x to the power of 8, like so. So to find the coefficient of 5, we can just do it straight away, because we know that the 8c something and that something will represent the power. So we have to do 8c5, because 8c5 will be equal to 3x to the power of 5, which is just the coefficient of x to the power of 5, which is what we want. And times by minus 2, and the power to minus 2 will be 8 minus 5, which is 3, like so. So 8c5 will be equal to, let me just type it out, 8c5 is 56 times 3 to the power of 5 is equal to 243 x to the power of 5, and minus 2 cubed will be equal to minus 8. And if you times everything, you will get an answer of minus 108,864 x to the power of 5. And that's the final answer, because this is basically the coefficient of x to the power of 5. And we just calculate it to double check, and that is correct. And then we have question 6. Expand the expression 1 over x plus 2x squared to the power of 4. So as usual, you just do 1 over x, just write it out, 1 over x plus 2x squared to the power of 4, it will equal to 1 over x to the power of 4 plus 1 over x, basically x cubed, times 4c1 times 2x squared plus the third term of 1 over x squared, because it's basically 1 over x to the power of 2, times 4c2 times 2x squared to the power of 2 plus 1 over x times 4c3 times 2x squared to the power of 3 plus 1 over x to the power of 0, which is just 1, so it doesn't really matter, times 4c1 times 2x squared to the power of 4. And let's write the answer down below here. So the first term, 1 over x to the power of 4, it is quite simple, it's just 1 over x to the power of 4, x to the power of 4. And then the second term, it'll be 1 over x to the power of 3 times 4c1 times 2. So let's just do 4c1 times 2 first. So 4c1 times 2 is equal to 8. So put in 8. So we know that as just now, it could result in a fraction because this is x squared. It's divided by x cubed. So it will result with 1 over x. So it will be 1 over x, which 1 times 8 is 8, so it becomes 8 over x. So plus 4c2, the third term is 4c2 times 2 squared, and it will get 24 as a coefficient. And the power, as you can see, x squared and x squared to the power of 2 will become x to the power of 4. Divided by x squared, it becomes x squared. So as you notice, the powers in the bottom are getting smaller and smaller in the pattern. In the fourth term, 4x cubed times 2 to the power of 3, it becomes 32. Oops, 32. Then you can work it out. X squared to the power of 3 divided by x, you will get 5, x to the power of 5. And then for the last value, 1 times 4c4 times 2 to the power of 4, because it's just 1 times 2 to the power of 4, which is 16, plus 16, and the power will be x to the power of 2 times to the power of 4, which is x to the power of 8. So x to the power of 8. And that's the answer. And moving on to the last question, find the constant term, which is a term that's independent of x with no x in this value right here. So remember, as I said just now, the independent of x is where the value has no x, it's just a constant. Like it could be like x to the power of 5, x to the power of 4, blah 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 blah, x plus 60 plus 1 over x. This term right here is the independent of x because it has no x value attached to it, it's a constant. So we're not going to expand everything up because it will be very time consuming and inefficient. So we know the general expression will be x to the power of 3 times by something 20cn, and the power of this will be 20 minus, so let's just rewrite this right here, times 20cn, and the power will be 20 minus n, times by 2 over x to the power of n. So we have to find a value for the power and this n and the n right here, the power, that if you get to the power of something for the denominator of x, it will cancel out this term right here. So these two terms have to cancel. And the term I can think of for n is n equals 15. Because if you raise this to the power of 15, it will be 2 over x to the power of 15, which is just 2 over 15 divided by x to the power of 15, right? But if you do this term right here, the most left term, the power will be 20 minus 15, which is 5. So x to the power of 3 to the power of 5 will be x to the power of 15. And you can cancel out. So let's just do that. With x to the power of 20 minus 15 times 20c15 times 2 to the power of 15 over x to the power of 15, and x cubed, and this term will mean it will cancel out because it will be x15 times 20c15 to the power of 2 to the power of 15 times this right here, and these two terms will cancel out, which will result in 20c15 times 2 to the power of 15, which we'll get a final answer of a big number, 508,035,072. And that's the final answer. And that's it for this video for questions for binomial theorem, and I hope you'll find it useful and helpful, and if you did, please leave a like and subscribe and ring the notification bell so that you don't miss out on any future videos. And if you have any questions related to binomial theorem or any other topics, you can leave them in the comment section and I'll reply to them, or you can drop me an email where my email is in my YouTube bio. And check my social media in the description, for example LinkedIn or YouTube or Instagram. And if you need any learning resources or any teaching resources, you can check out my website in the description, or you can type it out in your browser at www.MakesItEasy.com. And I hope you'll find it useful and helpful, and I'll see you all in the next video, which will be rules and examples for a new topic. But until then, stay safe and happy learning.